Welcome to today's Explainer. Right now, AI is basically reshaping our entire world, right? But today we're going to bypass all that hype and actually look under the hood. We're breaking down the specific architecture that makes these artificial intelligence models, actually learn.
To kick things off, think about this for a second. How does Netflix know exactly what you want to watch next? Or how does your smartphone instantly recognize your face the moment you pick it up, even if you're in a completely dark room? Well, these aren't just clever little parlor tricks. They actually rely on a wildly sophisticated computer architecture that was inspired directly by human biology.
All right, let's dive into this. Here's our roadmap for today. First, we'll meet the artificial brain. Second, the anatomy of a neural network. Third, how the network actually learns. Fourth, real-world applications. And finally, number 5, the good and the bad. Let's get right to it.
Section 1. Meet the artificial brain. Nature's supercomputer goes digital. So, to really wrap our heads around modern artificial intelligence, we actually have to look at the human nervous system first. A neural network is simply a collection of artificial neurons, they're called nodes, that process information, recognize patterns, and learn from experience. It's literally mimicking the way our biological brain cells work together.
It's honestly fascinating how perfectly these two worlds mirror each other. I mean, think about it. Where the human brain uses biological neurons and synapses to learn from real-world experience, the artificial network uses digital nodes and mathematical weighted connections to learn from massive chunks of training data. It's basically biology translated seamlessly into pure math.
Moving on to Section 2, Anatomy of a Neural Network, breaking down the layers.
Okay, so now that we know what a neural network is trying to imitate, let's break down the actual architecture that makes these artificial brains tick. How are all these nodes organized? Well, they're grouped into 3 main layers. First, you've got the input layer. That acts as the front door, taking in raw data directly from the user or the environment. Then comes the hidden layer. This is the engine room, right? It's performing all the heavy mathematical lifting to sniff out underlying patterns. And finally, the output layer delivers the final prediction. So it's input, process, output. Simple as that.
All right, quick pop quiz to see if you're tracking with me. Which layer of the network actually receives the data first? Things like image pixels or a temperature reading. I'll give you a second. Got it? If you said the input layer, you are absolutely correct. That is the network's front door for any incoming data.
Section 3, How the Network Learns, from Mistakes to Mastery. We've seen the static architecture, but let's see this whole thing in motion. It's a 4-step process. Step 1, input data is entered. Step 2, that information is mathematically processed by the hidden layer to find patterns. Step 3, it produces a final result at the output layer. But step 4 is where the real magic happens. If that prediction is wrong, the network actually improves itself through training. It uses that mistake to adjust its weighted connections. It's essentially learning from its errors over countless examples, moving all the way from initial mistakes to complete mastery.
Let's do one more quick knowledge check. Which layer gives the final prediction, like making the ultimate decision if an incoming email is spam or not spam? Think about the flow we just walked through. Yep, you guessed it. It's the output layer. It always delivers the final verdict.
Section 4, Real-World Applications, Neural Networks in Your Everyday Life.
Now, this step-by-step learning process isn't just some abstract academic exercise. It is actively revolutionizing practically every industry out there. Take healthcare. Networks are analyzing complex medical images for early disease detection. In banking, they're instantly verifying credit card transactions to block fraud. In education, they're powering totally personalized smart learning systems. Over in agriculture, they're predicting crop yields and weather patterns. And in transportation, they are the literal brains steering self-driving cars through traffic.
But hey, we don't even have to look at massive global industries to see the impact. Just look at your own daily routine. That abstract math we were just talking about, with the hidden layers and weighted connections, that's exactly what translates languages instantly on Google Translate. It's what allows voice assistants like Siri or Alexa to understand what you're saying. It reads handwriting. And yeah, going back to what we asked at the very beginning of this explainer, it is the exact technology categorizing your viewing habits to recommend your next favorite movie on Netflix.
Which brings us to Section 5, the good and the bad, balancing the AI hype.
As enthusiastic as we might be about all this, we definitely have to balance the AI hype with reality. The advantages? Totally undeniable.
Neural networks learn from experience, recognize ridiculously complex patterns, handle massive datasets flawlessly, and drive awesome automation. But to achieve all that accuracy, there are some serious limitations. They require a staggering amount of massive data to train on. Plus, all that intense math in the hidden layers demands high computing power, which leads to super long training times. So they're brilliant, but they are absolutely not cheap or easy to build.
And that brings me to a final limitation and a really provocative question to ponder. We know these networks are incredibly smart at finding patterns, but it is notoriously difficult to understand exactly how they make their decisions. Those hidden layers, they're often basically a black box of complex math. So if we're going to rely on artificial brains for things like steering our cars or diagnosing medical conditions, how comfortable should we be when we can't fully trace their logic? It's a fascinating mystery right at the heart of AI. Anyway, thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.